Okay, so now we're on page 2, numbers 20 through 27. Compare the graphs of the pair of functions. Describe how the graph of the second function relates to the graph of the first function. So if we look at these two functions, they are both negative to absolute value of x. So they have both the parent function. The only difference is this minus 3. And we should know by now that's a vertical translation down 3 from the other graph. And that's it on that one. Okay, so this one says solve the system by substitution. You don't need to do substitution. We never really did substitution with the system of 3 equations. So we're going to use linear combination. And I notice here I have an equation that doesn't have y in it. So I'm going to put these two together and eliminate y. My y's already have opposite coefficients, 1 and negative 1. So I can just add them together. X plus negative x is 0. Y plus negative y is also 0. 3z minus 2z is z. And negative 4 plus 5 is 1. So by adding those together, I get that z equals 1. Now I can plug that in here. 2x minus 1 equals negative 3. So I guess we'll do a combination of linear combination or elimination and substitution. We'll add 1. We get 2x equals negative 2, so x equals negative 1. And now we can go back to our first equation, x plus y plus 3z equals negative 4. And we'll plug this in, negative 1 for x, plus y plus 1 for z equals negative 4. That's negative 1 plus y plus 3 equals negative 4. That's y plus 2 equals negative 4. Just randomly moves on me sometimes. And so subtract 2, so y equals negative 6. And I get, in order, x, negative 1, comma y, negative 6, and z is 1. That's my final answer. So that is not as daunting as it might have seemed at first. Moving on to a little more complicated one, using elimination again to solve this system. So I can use any variables to eliminate. The one I think is going to be easiest here is the y's, because 4, 2, and 1, these are common factors. If 4 is a factor of 2, 1 works nicely. So we're going to eliminate the y again on this. I get, let's see, negative 4x plus 4y minus 2z equals negative 8. It's so important we copy correctly on these problems. I'm going to multiply the second equation by 4. So I get negative 12x minus 4y plus 16z equals 0. Let's not forget the 0 times 4 is 0. And then I get negative 16x. My y's eliminate. I get plus 14z equals negative 8. Now I have to use my second equation, or my third equation, sorry. So I have 2x minus 2y plus 3z equals negative 4. I'm going to multiply this equation by a negative 2 to make that positive 2y. So I'm going to erase this so I don't mess up and multiply by negative 2. So we get 6x plus 2y minus 8z equals 0. 2 times, or negative 2 times 0. So I get 8x, the y's eliminate again, minus 5z equals negative 4. Now these are all even over here, so I'm going to divide by 2 to make it a little bit easier for me. Smaller numbers, better for me. Plus 7z equals negative 4. And then we get, we can just add that together now that we have an 8x and a negative 8x, plus 7z equals negative 4. And we get 2z equals negative 8. So z equals negative 4. Then I can plug that back into either one of these equations, this one, or even this one if I wanted. I'm going to just choose to plug it in right here, negative 8x plus 7 times negative 4 equals negative 4. That's negative 8x minus 28 equals negative 4. Add 28, and we get negative 8x equals 24, divided by negative 8, and x equals negative 3. And then we can plug those back into the original equation. Negative 4 times negative 3, negative 4 times x, plus 4 times y, which is what we don't know. I don't really need those parentheses, minus 2 times negative 4 equals negative 8. So we get 12 plus 4y plus 8 equals negative 8. We get 4y plus 20 equals negative 8. Subtract 20, 4y equals negative 28. And divide by 4y equals negative 7. So my ordered triple is negative 3, negative 7, negative 4. And that's my answer. Number 23 and 24 are solve the inequalities by graphing. Inequalities require shading. So we have, let's see, they're both in y equals mx plus b form. So it's not going to be a perfect graph, especially on this. It's kind of hard to do good ones. Negative 4, the first one has a y-intercept of negative 4. Start there. A slope of negative 3 over 1. So I'm going to go down 3 over 1. I'm going to go up 3 to the left 1. Greater than or equal to, so it's solid. And greater than is shading up. The second equation starts at positive 1. I'll do that in a different color. Let's do that in red. Positive 1. And the slope is 1 over 3, which is up 1 over 3. Down 1 over 3. Less than or equal to, so it's again solid. And less than is down. So where are the arrows pointing at each other? It's right in here. And that's your shaded area. Okay, let's look at the next one. Y is greater than 3x. That starts at 0, 0, and has a slope of up 3 over 1. So up 3 over 1. And it is solid because it's greater than. Please excuse my messy lines. And greater than is up. We're going to shade up. I'll do the absolute value. Absolute value function is a v. So the vertex is at negative 2, negative 3. So negative 2, negative 3 is here. I have a slope of 1, up 1 over 1. And then I go up 1 to the left 1, up 1 to the left 1. Okay, because that's my slope. And it's greater than, not or equal to, so I'm going to make it dashed. Okay, so I maybe missed that point there. And greater than is shaded up as well. So our shading here is happening between that line and this part of the absolute value. So our shading is going on right in there. And the last set for this page, factor the expression, factoring 6x squared plus 40x plus 5. So when I have a perfect square and a perfect square, I want to see if 4x and 4x and 5 and 5 will give me this 40 when I add the outside and the inside. That's 20x plus 20x. That is right. Everything's positive. So it's 4x plus 5 squared. Or 4x plus 5 times 4x plus 5. Now, this is a multiple choice test, so you'll see it'll be written one of the two ways. Number 16 is a difference of two perfect squares. So that's 3, my stylus is being weird. 3x plus 4 and 3x minus 4. You need to recognize these and be able to factor them pretty quickly. And lastly, number 27, rewrite in vertex form. So we're going to use completing the square. Y equals x squared plus 10x plus 16. I'm going to use the method where I keep everything on one side. So I have x squared plus 10x. I'm moving the 16 outside the parentheses. I'm going to complete the square on what's inside because I don't have a coefficient on the x squared. If I did, I would need to divide everything by that. So I take my b term, divide it by 2, and square it. We get 25, right? 5 squared. I'm going to add 25 inside the parentheses, but to keep my equation balanced, I need to subtract 25 on the outside of the parentheses. If I'm doing it on the same side, I need to make sure it stays the same. So if I add 25, I have to subtract 25. Then I'm going to factor this, y equals x plus 5 squared. And then 16 minus 25 is 9, so plus 9. And it is done. There's my vertex form, y equals x plus 5 squared. Sorry, that's not plus, it's minus. Minus 9. And my vertex, if you're asked for it, is -5, -9.